Preparing for a ETL developer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is ETL, and what does an ETL developer typically own in a data pipeline? ETL is the pattern of extracting data, transforming it into trusted business-ready form, and loading it into a target like a warehouse. In practice, I first understand source contracts, volumes, latency, and data quality rules. Then I design transformations, staging, validation, and recovery. A good ETL job is not just moving rows. It is repeatable, auditable, performant, and safe to rerun after failures. While answering, focus on extract, transform, and load responsibilities, source-to-target mapping, data quality, scheduling, monitoring, and why ETL ownership goes beyond simply moving files or rows. Question 2. What is the difference between ETL and ELT, and when would you choose one over the other? ETL transforms data before loading it, usually in an ETL engine or staging layer. ELT loads raw data first and transforms inside the warehouse. I choose ETL when data must be cleansed, masked, or standardized before reaching the target. I choose ELT when the warehouse has strong compute, storage is cheap, and analysts need raw history. Modern cloud stacks often prefer ELT, but sensitive or regulated data may still require ETL. Make sure to cover where transformations happen, traditional warehouses versus cloud warehouses, performance, cost, governance, raw data retention, and how tools like Snowflake, BigQuery, or Redshift influence the choice. Question 3. How would you design an incremental load instead of a full load? For an incremental load, I identify what changed since the last successful run. Common approaches are updated at timestamps, increasing IDs, source change tables, or CDC logs. I store a high watermark only after the batch completes successfully. I also handle deletes, late records, and duplicates using merge logic. Compared with full loads, incremental loads are faster and cheaper, but they need careful audit checks to avoid silently missing changes. In your answer, talk about watermark columns, timestamps, surrogate keys, change tracking, late arriving data, reconciliation, restartability, and why incremental loads improve runtime and reduce source system pressure. Question 4. Explain slowly changing dimensions. How do Type 1, Type 2, and Type 3 differ? Slowly changing dimensions handle changes in descriptive business attributes. Type 1 overwrites old values, so no history is kept. Type 2 creates a new version with effective dates, expiry dates, and a current flag, preserving history. Type 3 stores limited history in extra columns, like previous region. I usually pick Type 2 for audit and historical reporting, Type 1 for corrections, and Type 3 only when the business needs 1 or 2 prior values. Be sure to mention dimension history, overwrite versus versioning, effective dates, current flags, surrogate keys, business reporting needs, and practical examples like customer address or product category changes. Question 5. How do you handle data quality issues in an ETL pipeline? I treat data quality as part of the pipeline, not as an afterthought. I add checks for nulls, data types, ranges, duplicates, referential integrity, and business rules. Invalid records go to a reject or quarantine table with error reasons. For critical failures, I stop the load and alert owners. For tolerable issues, I load valid records and report exceptions. The key is traceability, because users must know what was accepted, rejected, and why. While answering, include validation rules, null checks, referential integrity, duplicate detection, quarantine tables, alerting, data profiling, thresholds, business rule ownership, and how to prevent bad data from corrupting downstream reports. Question 6. What is change data capture, and how is it useful in ETL? Change data capture identifies row-level changes in source systems, so pipelines don't repeatedly scan entire tables. It can use database logs, triggers, timestamps, or vendor change tables. In an ETL design, I consume inserts, updates, and deletes, preserve ordering, and merge them into the target. CDC is valuable for large operational systems because it reduces source load and supports near real-time data. The tricky parts are deletes, schema changes, and replay handling. Make sure to cover insert, update, and delete capture, log-based CDC, timestamp-based approaches, reduced load windows, near real-time ingestion, ordering, deduplication, and downstream merge handling. Question 7. How would you make an ETL job idempotent and restartable? An idempotent ETL job gives the same result even if it is rerun. I use batch IDs, staging tables, deterministic transformations, and merge logic instead of blind inserts. I update checkpoints or watermarks only after the target commit succeeds. If a run fails halfway, I can clean the batch, replay from staging, or resume from a safe checkpoint. This matters because production pipelines fail from network issues, bad records, or target locks. In your answer, discuss rerun safety, checkpoints, staging tables, transaction boundaries, merge upsert logic, batch IDs, audit tables, high watermarks, and cleanup after partial failures. Question 8. What techniques do you use to improve ETL performance for large datasets? I start by identifying the bottleneck: source extraction, transformation CPU, network, or target loading. Then I use partitioned reads, parallel processing, bulk loads, and set-based SQL instead of row-by-row logic. For files, columnar formats like Parquet and compression help. In databases, indexes are useful for lookups, but may slow heavy loads, so I manage them carefully. Good performance tuning is measured, not guessed, and every optimization should be validated with runtime metrics. Be sure to mention partitioning, parallelism, push-down optimization, bulk loading, indexing strategy, avoiding row-by-row processing, file formats, compression, resource tuning, and measuring bottlenecks before optimizing. Question 9. How do you handle duplicates in an ETL process? First, I clarify what duplicate means for the business. Sometimes it is the same primary key, sometimes the same email and date, and sometimes a fuzzy match. Technically, I use natural keys, unique constraints, hash comparisons, or window functions like row number to keep the latest valid record. I also design retry-safe loads using merge statements. The main point is that deduplication should be rule-driven, because removing rows blindly can destroy legitimate business events. While answering, cover natural keys, surrogate keys, deduplication rules, window functions, source system duplicates, exact versus fuzzy matches, business rule clarification, and preventing repeated inserts during retries. Question 10. Explain the difference between a staging area and a data warehouse target. A staging area is a controlled intermediate layer where extracted data lands before final transformation or loading. It may contain raw or lightly validated data, plus batch metadata and error details. The warehouse target is modeled for analytics, reporting, and consistent business definitions. I use staging to isolate source issues, support restarts, compare counts, and perform transformations safely. Without staging, failures and bad source changes can directly impact production reporting tables. Make sure to cover temporary landing, raw versus cleansed data, auditability, transformation isolation, restartability, performance benefits, schema differences, and why staging protects the warehouse from unstable source data. Question 11. How would you validate that an ETL load completed correctly? I validate at multiple levels. At the pipeline level, I compare source and target counts, rejected records, and batch audit status. For important numeric fields, I use control totals or checksums. For transformations, I test business rules with sample records and edge cases. I also monitor null rates, duplicates, and referential integrity. A load is complete only when technical reconciliation and business validation both pass, because matching row counts alone can still hide transformation defects. In your answer, include source-to-target reconciliation, record counts, checksum or hash totals, control totals, sampling, duplicate checks, audit tables, automated tests, and business-level validation with stakeholders. Question 12. What are fact tables and dimension tables, and how do they affect ETL design? Fact tables store measurable business events, such as sales, clicks, or payments. Dimension tables store descriptive context, such as customer, product, date, or geography. In ETL, I define the grain of the fact first, then resolve dimension keys before loading facts. I also handle late-arriving dimensions with inferred members or retry logic. Good dimensional modeling makes reports fast and understandable, but poor grain decisions create double counting and confusing metrics. Be sure to discuss measures, descriptive attributes, grain, foreign keys, surrogate keys, conformed dimensions, late-arriving dimensions, star schemas, and why modeling decisions drive transformation logic. Question 13. How do you handle schema changes from source systems in ETL pipelines? Schema changes are normal, so I design detection and response. If a source adds a nullable column, the pipeline may continue while metadata is updated. If a column is renamed, removed, or changes type, I want the job to fail loudly with a clear alert. I use schema checks, source contracts, version mappings, and impact analysis before deployment. Silent schema drift is dangerous because it can produce trusted-looking but incorrect data. While answering, mention schema drift detection, backward compatibility, metadata-driven mappings, nullable columns, versioning, contract testing, alerting, impact analysis, and coordination with source application teams. Question 14. How would you orchestrate and monitor multiple dependent ETL jobs? I model pipelines as dependencies, not just cron jobs. For example, dimensions should load before facts, and downstream marts should wait for warehouse tables. In tools like Airflow, I define DAGs, retries, SLAs, parameters, and alerts. Each task logs batch ID, counts, duration, and failure reason. For upstream failures, I stop dependent jobs rather than producing partial data. Good orchestration gives visibility, controlled recovery, and confidence during backfills. Make sure to cover dependency graphs, scheduling, retries, SLAs, alerting, backfills, parameterization, logging, lineage, tools like Airflow or Control-M, and handling upstream failure gracefully. Question 15. What security and compliance practices should an ETL developer follow? ETL pipelines often touch sensitive data, so security has to be built in. I use least privilege access, encrypted connections, secure file transfer, and manage secrets instead of hard-coding passwords. For PII, I apply masking, tokenization, or filtering based on downstream need. I also maintain audit logs showing who accessed what and when data moved. Compliance is not only a legal checkbox, it protects customer trust and reduces blast radius during incidents. In your answer, talk about least privilege, encryption, masking, PII handling, access controls, secrets management, audit logs, retention policies, secure file transfer, and compliance requirements such as GDPR or HIPAA. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.